Hi everyone, welcome to our video on the algebraic techniques basic rules for finding limits. So there's three different ways to find limits. We can use graphing calculators or a graphing program. We could create tables, and then we could also use algebraic techniques. Sometimes we could use all three to really verify we have an answer. Sometimes only one or two of them would work. So, but let's show our third way. So the algebra techniques. Okay, and to start that off, we just have some basic rules that we can follow to evaluate some of these limits. Most of them are pretty straightforward. We'll block. I'm going to just kind of group those ones and group these two and show how they work in our problems. So with this brace, this is like our example 1 and 2 here. Let me go ahead and just we'll do a star. So it's using these rules here to help us with example 1. And all it is just really we're going to evaluate and substitute. So again, without even knowing these rules, without even looking at it, we could probably kind of figure out what needs to be done. So let's show this one. I'm going to rewrite it. So when you have a limit, so the limit can just kind of hang out front. And when you have multiple terms separated by pluses and minuses, that means you could rewrite as multiple limits. So for this, I'm going to write this as the limit as x goes to 2 of the 5 f of x, and then minus the limit as x goes to 2 of the 2 g of x. Okay, it's almost like it's distributing. So it's like this limit is going to both. And then, well, this 5 here and this 2 here, we can take them out and put them in the fronts of each of their own respective limits. So it's just I'm gonna move that right out front. So I have 5 times the limit as x goes to 2 of f of x minus, let's put this 2 out front, the limit as x goes to 2 of g of x. And then in our problem, it told us what those were equal to. So this limit, let's box it in blue. They're saying right there, that whole limit, so it's just a substitution. They're saying this whole thing is the same thing as 25. So this is the same thing as just 25. So I still have the 5 out front that's going to multiply it. And then I still have minus 2. And then they said this whole thing right here, in the red, the whole limit is just negative 4. So that's this portion. So minus 2 times, they're saying this limit is just negative 4. And then now it's just order of operations. We could plug this all in and simplify. So we've got 5 times 25 is 125. Minus a negative would become plus. 2 times 4 is 8. And so we have 133. Okay, so it's really more of an order of operations problem when they set it up where they give you just random limit values like this. Okay, and then for the second one, again, we can kind of break it apart into its own things. So this limit, each time you see your own function, it goes to each of them separately. Okay, so this is the same thing. So it's almost like distributing, but with this, we could split them into 2. So I'm using this rule with the product. So this dot, so we were using these rules. I just haven't mentioned them just to jump into it. And so what we have is the limit as x goes to 2 of the square root of f of x times the limit as x goes to 2 of the g of x plus the limit as x goes to 2 of 5. Okay, so what we have here, well, let's rewrite this one, for this first one, that square root. That square root can really do the square root of the whole limit eventually, just like that. And then still we have times the limit as x goes to 2 of g of x plus the limit as x goes to 2 of that 5. All right, and then, well, like the last one, we have some of these ready to go. We have this here. They say is 25. Okay, so I'm going to put that right down below. It's going to kind of squeeze into that other one. So I have the square root still there. So the square roots, and then they said this limit that I put in the bracket is just 25. And then we already have this limit as well. They said it is negative 4. And then the last one there, the plus, the limit as x goes to 2. Well, this is a special one where it's just a constant. Okay, so it's not listed in any of these rules. I'm going to add it just to the side. So if you have the limit as x goes to something, I'm just going to use a of a constant, so just a regular old number, that means it is the constant. Okay, so that's all it is. It's just that special rule. And the reason for that is, well, say you had y equals 3, so this is a constant function. So that means it's a horizontal line. 1, 2, 3, at 3. So no matter what, wherever I am as an x value, my y value is always 3. So that's how it's looking at it. So this here, this part here is just that answer there, the 5. Okay, so it's just that constant. So that's another very quick rule that we can apply. Okay, and then now anyway, it's just now simplify a little bit more. So square root of 25 is 5 times negative 4 plus 5. And then, well, this is negative 20 plus 5 would be negative 15. And that's it. Okay, so that's applying some of these basic rules there. So that was the first group where it's really just pick apart. If they give you these limits as some number, so they're just equal to some random number, well, then we could pick it apart and eventually sub in those numbers into our expression. Okay, so for number 2 here, the example 2, let me kind of block that off. It's kind of in the way. Here they don't tell us what limits are like this, where I have them boxed in blue and red. They just say evaluate the limit. Okay, and we have these expressions. All right, well, that's where these rules are going to come in. So let me do double star. So that's these. Again, we'll continue to use these rules throughout. It's just these are special cases that are ready to go for us. So on this problem, I'm going to so this is a polynomial, 3x to the 5 minus 2x squared plus 6. So that means all you have to do is just plug in this negative 1 into all your x's to get your answer. So this is the same thing as 3 times negative 1 to the 5th minus 2 times negative 1 squared plus 6. And then from there, it's just simplify. So this is negative 3. Well, yeah, it is negative 3. Negative 1 to the 5th is negative, and then times 3 is negative 3. This negative 1 would get squared to become positive 1, times negative 2 is still minus 2, and then plus a 6. And then now we can simplify, and it is just 1. Okay, so that's what this limit is. So if it's a polynomial of any kind, so that's this first bullet in the double-starred set of braces, all you have to do is plug it in. It's just saying it is equal to the same thing as when you plug it in. You don't have to worry about anything. Okay, and then it's the same deal with rational functions. As long as the denominator is not 0, we can just do the same thing that we just did. So on this, all I have to do is take this 4 and plug it into those x's that I see. So I have 4 squared over 4 plus 2. And I'm just putting the parentheses to show that I've subbed them in. And then, well, now do your order of operations. We have 4 squared is 16. And then 4 plus 2 down below is 6. And then we could divide these. They're each divisible by 2, so we have 8 thirds. And that's that. Okay, so that's using these rules. Okay, so we'll continue to apply them. These second ones, the example 2, is often a first step that we do all the time to see if we can answer it right away. If it doesn't give us a number, so here we got nice numbers, 1 and 8 thirds. If it gives us something like an undefined, well, then we have different strategies that we want to do. All right, and anyway, and those will be in our next video. So this one we're going to put a pause on, and we'll come back. So for now, thank you for watching. If you do have questions, please let me know, but I'll see you next time.